They are not coming early and study. Alone my office inside. Take the stone and throw on it. You take another hockey. I expected you will come by 4 o'clock yesterday. Yesterday varla, day before yesterday varla me 4 o'clock. Today also you did it. Birthday wa. Then why he is shaking his hand? CSK? Okay, fine. How are you, Sri Krishna? Other BGP? Yeah, not coming. Shall we brief for 5 minutes in the last class what we discussed? What we started in last class means we started studying which are the charges moving. About the moving charges, we started talking. We said that if charge is moving, current will be passing. Sir, charges na two type of charges we talked. Positive charges, negative charges. Yes or no? Current order direction, positive charges in the direction of homo, current order direction and the direction of the negative charges in the direction of homo, current order direction and the opposite. That's what we said. One thing. Yes or no? Inside the conductor, electrons will move randomly when there is no electric field. Yes, that random motion is because of the thermal, because of the temperature we say. And the any current will be presented means it is moving na electron. Any current will be presented, no current. Why? Because the net value will cancel out each other. And the total average velocity will be zero there. Average velocity will be zero there we say. Yes or no? After that, when we apply the electric field, we said that the electrons will be drifted opposite to the direction of the electric field we said. Electrons will be drifted opposite to the direction of the electric field we said. Correct? Electrons will be drifted opposite to the direction of the electric field. So, if an electric field is left to right means electron will move from the right to left. Who will produce that electric field? Take it with the hand. Who will produce that electric field means some kind of cell, battery, that kind of stuff we have to use, we said. Correct? Yes or no? So because of the presence of electric field, a force will be acted upon the every charge. Am I correct or not? But that force will result into acceleration. Yes, but the effect of acceleration is getting cancelled out. The electrons are moving with a constant drift. So that constant drift velocity Vd is equal to what? We have derived, we got one formula. Minus E, capital E, by M into tau. E tau divided by M. Minus, what is that minus indicates? What is that minus indicates? Electrons are moving opposite to the direction of the electric field. Electrons are moving opposite to the direction of the electric field. Yes, that's what we studied, right? After that we studied relation between current and that drift velocity. So what we got, that relation I is equal to minus NEAVD. What is the drift velocity we got? What is the current in terms of drift velocity? I is equal to minus NEABD. Here also I and E are opposite in direction, that's why minus you are getting. Yes or no? The charge is negative. Current will be opposite to that. That's why you are getting minus. So only magnitude if I ask what is the I? I is equal to NEABD. Keep this in. I is equal to NEABD. Understood everybody? Up to here we discussed in the last class. Sir, we finished within simple 5 minutes right now. The same only we discussed in the last class, right? But reasons we have given in the last class. Understand? Now we have given only conclusions. That's why I went. Understand? In today's class, what we are going to study means, first of all, one special term, current density, we are going to study. What we are going to study in today's class? Current density, we are going to study. Then after that, after current density, we are going to study, what we are going to study? Ohm's law. What we are going to study? Ohm's law. What is Ohm's law? V is equal to IR, we are going to study. So, Ohm's law, we are going to study little deep. While defining Ohm's law, we will get one term called resistance. What are the factors this resistance will depends upon, we will study. And Ohm's law, we know V is equal to IR. From our childhood we know. But another form of Ohm's law we will study. What we will study? Another form of Ohm's law we will study. Is that clear? And after that, the relation of this Ohm's law in terms of drift velocity we will write. This Ohm's law in terms of drift velocity. In your childhood you said that resistance depends upon material properties as well as the length and area of cross section. But resistivity doesn't depends upon the length and cross section but depends upon the material. Why it is depending upon the material reason you will find here. In 10th we studied it is a material property, we didn't study anything deep. But exactly why it is a material property we will study. Is that clear? And temperature dependence of the resistance we will study. Temperature dependence of the resistance we will study. Clear for everybody? Then after that what we will study means, there are some materials which violates the Ohm's law. There are some materials which violates the Ohm's law. About that materials we will study. After Ohm's law, we will study energy and power. Energy and power. At the end of today's class, we will conclude why we need transformers. At the end of today's class, we will conclude that why we need transformers. Is that clear for everybody? Shall we start now? So, what I have to start, tell me? Current density. Clear? So, current density is nothing but which is indicated by J. Current density is indicated by J. Okay? Current density is indicated by J, which is nothing but I by EA. Current density is equal to I by A. I by A. Clear? Current density J is equal to I by A. Understood? So here you just observe one thing. From here I is equal to what I can write? J. A is a vector quantity. It will be along its area direction n cap. J is also a vector quantity. Keep in mind. J is also a vector quantity. Current density is having the direction. Keep this in mind. Its direction is along the electric field, that we will prove. Current density direction is along the direction of the electric field. We will prove that. Understand? So what is this relation between this means? It is J dot A. Nothing but JA cos theta we will get. JA cos theta we will get. So how it will look like means, one second, let me show you that. Here you can see this. Here you are able to see, right? So what is the J formula? J is equal to I by A. From here I by A. What is I formula? Tell me. J is equal to NEA VD divided by A, you write. So what it will become? A cancel, just NEVD. Remember this. So current density J is equal to NEVD. J is equal to NEVD. Someone can tell me what is the formula of VD? N into E into, what is the formula for VD? What is that? Small e, capital E by M into tau. Am I correct or not? So from here, you are getting J is equal to N E square E by M tau. Everybody are here constant. So constant means scalars. E alone is the vector. Correspondingly, J also vector. They both will be in the same direction. They both will be in the same direction. So keep that in mind. J is equal to N E square tau by M. E here. N E square tau by M E. Is that clear for everybody? Yes. Yes. So, and you can observe here, as I said earlier, I is equal to J dot A. Keep this in mind. I is equal to J dot A. Nothing but I is equal to JA cos theta. What is that theta? Tell me. Between the J vector and A vector. Theta is the angle between J vector and A vector. Is that clear? Understand? Fine. Now we are going to enter into Ohm's law. Everybody knows what is Ohm's law. V is proportional to I. Correct? V is proportional to I. But observe carefully. When V is proportional to I, he said some conditions. There should be no change in the temperature. See this. If the physical states remains unchanged. What should be remains unchanged? Physical states. What do you mean by physical states, sir? What do you mean by physical states? Temperature and mechanical strain. Meaning, no one should pull it. For example, these wires are there, right? They were one beside each other. Correct? In some places, villages, you can observe, they will tie a stone to the thread, stone, they will put over the wire. Why? Because they will put it little bit down so that it will not touch to each other. So when that weight is on that wire, it will be pulled down, right? There is a chance it will undergo elongation, right? Because of application of force that you are avoiding. Why, sir? அந்த மாதிரி elongation இருந்தா என்ன ஆகும்? It will lead to change in the length. When change in the length happens, its resistance will change, right? Clear? That's why you are eliminating mechanical strain. And temperature, material property it is. Meaning, material property depends upon the temperature. That's why you don't want to change the temperature. Is that clear? So temperature should remain constant and mechanical strain should not be there. Mechanical strain should not be there. Mechanical strain should not be there means no force should be on the wires. No force should be on the wires. Is that clear for everybody? Yes. So now observe here, I is proportional to V. Clear? I is equal to V. See here, we have plotted I versus V, right? Slope of this curve is not resistance. Not resistance. IV curve slope is not resistance. Slope of VI curve only it is resistance. Remember this. Slope of VI curve. V should be on the y axis. I should be on the x axis. It should be resistance. Remember, we are having a formula y is equal to mx. Am I correct? Y is equal to mx. Here m is the slope, right? Compare the equation with that. V is equal to Ri. So who should be the y-axis? V. And who should be the x-axis? I. That time only slope of that line will leads to resistance. Sir, other time what it will lead, sir? It will leads to the not resistance. Then what it is? Conductance. What it is? Conductance. It's not the resistance. What is your confusion? You will do that. You will get reverse of this one. You will get the answer. Okay. Finally, you will reverse it. We got this. That's reverse only you are that value. We have conductance ko resistance ko relation irukku. Resistance symbol R ma. Yes or no? Conductance symbol. Conductance symbol. It is sigma. Conductance symbol sigma. But actually conductance ko resistivity ko relation irukku. Conductance ko resistivity ko relation irukku. What is that relation? So I can tell instead of correct. Conductance only it is. Conductivity ko resistivity ko relation irukku. Conductivity ko resistivity ko relation irukku. Keep that in mind. Understand? We will discuss that also in this class. Don't worry. Understand? Now. But you are clear right here. Suppose if I draw one more line like this. So I indicated this is R1, this is R2. Which is big resistance? R2 is greater than R1. So which angle is more? That is more resistance when it is VI graph. When it is IV graph, which angle is less? That will be more resistance. That will be more in IV graph because it is reverse. Understand? You have to be careful which graph you are seeing. VI graph or IV graph. I hope you are clear with this, right? You have to remember this condition ma. Y is equal to mx. Correct? So V is equal to Ri. Y is equal to mx plus c. It is there. I am not considering that c. Why I am not considering means because it is passing through the origin. When voltage is not there, current will be 0, right? Obviously, this C will be 0. Understand? Fine. So, what is the symbol for resistance? It is R and its unit is ohm and unit of the symbol is this. What is this name? Anybody? Capital omega. Its name is capital omega because this is small omega. Clear? Because like capital A, small a, here also capital omega, small omega we are having. Understand? Now we are talking. What is that resistance? You said resistance, one guy came into picture, right? V is equal to IR you said. Yes. That R is the resistance you said. Correct, right? Resistance is nothing but opposition offered by the conductor to flow of electric current. What is that resistance means? Opposition offered by the conductor to the flow of current. That's it. To the flow of current. It is the resistance offered by the conductor for the flow of current. Am I correct or not? So observe carefully. From here, what is R is equal to? R is equal to V by I. R is equal to V by I. When can I, how do I define 1 ohm? If V is 1 volt and I is 1 amp, then current is 1 ohm only, right? So if I maintain 1 volt potential difference, if 1 ampere current is passing, I can tell the resistance of that conductor is how much? 1 ohm. The resistance of that conductor is how much, I will tell? 1 ohm. Am I correct? If I apply 1 volt potential difference, if 1 ampere current is passing, what is the resistance of that conductor? 1 ohm. Is that clear? Yes. So that is not that much important here. Value of resistance depends upon nature and dimensions. Keep this in mind. Nature means which type of material, whether it is a metal, whether it is a conductor, semiconductor, insulator. Material, it will depend whether you are taking copper, iron, like that. Nature of the material, it will depend. Who will depend nature of the material? Resistance. Not only nature, dimensions. Are you taking small wire or big wire, thin wire, thick wire? Everything it will depend. Is that clear for everybody? Understand? Thin wire, thick wire, everything it will depend. Yes. Units we know. It's a dimensional formula. Sometimes they ask the dimensional formula. So please remember it. What is that? ml square t power minus 3 a power minus 2. ml square t power minus 3 a power minus 2. Write down its a dimension. Not only this, you try to remember dimensional formula of all the quantities. 1 or 2 questions I saw in 2 to 3 years. They ask directly dimensional form. Understand? At the end of your textbook, they have mentioned the dimensional formulas. You write afterwards. I'll send this PDF. Today I'll send someone remind me. I'll share this PDF. See, I converted the PPT to PDF so that easy now. Yes or no? Struggled in last years. Okay, fine. Let's see now. Factors on which resistance depends. I know, sir. I studied in 10th class. R is proportional to length. R is inversely proportional to area of cross section. Altogether, R is proportional to L by A. Remove the proportionality. Keep a constant. That constant is rho L by A. What is this guy name? Resistivity. Correct? Its name is resistivity. Understand? Okay, resistivity. Understood, everybody? Yes, sir. I know. So, observe here. R is equal to rho L by A. One of the important relation. What is that rho is called? Resistivity. Rho depends on the material. Here in this class we are going to prove how it is going to depend upon the material. How it is going to depend upon the material. We are going to discuss. And why it is not depending upon the L and A also we will confirm. Is that clear for everybody? Yes. And conductivity sigma, which is equal to 1 by rho. Conductivity sigma is equal to what? 1 by rho. Reciprocal of resistivity is conductivity. Reciprocal of resistivity is conductivity. Clear? Yes. Fine. Now, I said right Ohm's law. What is Ohm's law we know? V is equal to IR. That is our childhood. Yes, right, you became 12th now. In 12th class, another equivalent form of Ohm's law we are going to write. Okay, what is that another equivalent form of Ohm's law means? Let's see. If you remember, we already wrote this. Yes, J is equal to sigma into E. Sir, you remember I wrote J is equal to one big formula we wrote. Okay, we'll come back to that. No need. We'll come back. What is that sigma? We'll rewrite afterwards. Now observe. V is equal to IR we are having a correct? Yes. So I R is equal to what? Tell me. Just now you wrote rho L by A. That is what your V. According to V and E relation, if there is a potential difference of V across the length L, what will be the electric field? E is equal to V by L. That means V is equal to இது தெரிஞ்சிச்சா இது ஈஸியா புரியும் உங்களுக்கு. This we discussed with very important mark. Am I correct or not? Relation between E and V. E is equal to V by L. So V is equal to EL. Substitute there. EL is equal to I rho L by A. L cancel. What is this I by A? I by A? J. Okay, sir. E is equal to rho J. E is equal to rho J. It is telling very clearly rho is a constant, correct? E is a vector. J is also a vector. They both will be in the same direction. They both will be in the same. That's what I mean. The current density is also directed along the E. The current density also directed along the E. Keep this in. J and E order direction always same. Understand? J and E direction will be always same. So this rho, replace this, what it will become? Sigma you replace. J is equal to 1 by rho E. So from here, J is equal to sigma E we can write. J is equal to sigma E we can write. Understand? Is that clear or not? This is another equivalent form of Ohm's law. This is equivalent form of Ohm's law. Who will use this? What is that equivalent form? Tell me, ma. J is equal to sigma E. Clear? Now Ohm's law from drift of electrons. That is nothing but I am trying to write Ohm's law in terms of the drift velocity components. Okay. So you remember V is equal to what? IR. I is equal to what? NEAVD into R. Yes, sir. This is nothing but Ohm's law in terms of the drift only. Am I correct or not? But I am applying what is the drift VD formula. What is the VD formula? NEA into VD is what? E capital E by M into tau R. Correct? Yes or no? Yes. Observe carefully. Observe carefully. What will you get from? What is V means in terms of capital E? E into L only, right? EL is equal to NEA. Already I did this. EE by M tau capital R. Sir, you can cancel L somewhere. R also replace it. What will you get? R also replace it. What will you get? I will write that. NE square E by M A rho. Oh, sorry. Tau you want me to tau. Rho is nothing but sir, R is nothing but rho L by A cut L cut verum rho இருக்கும். Very good. So that is what your E, right? A also cut. Very good. Yes. What you are left with is we didn't get a J. Something we missed. Anything I missed there? We got E is equal to NE square E by M tau rho. One second. 1 second. I want J. Yes, ma. J. J into. Okay, 1 second. Stop here. Yes, ma. J. But E irukku maatinganga. J irukano, E irukano. Okay, leave that. Don't worry. So this is one relation. You remember it like this. What is this relation? V is equal to N E square. Am I correct? A S and divided by M. Okay. Abram E tau R. Like that we turn. Leave this. Understand? Okay. Like this you leave. Okay. Fine. J. Yes, we got it. Earlier we did that. We got J is equal to N E square tau by M into E. I am taking this equation which we got earlier. Can you rewrite that? Write that J is equal to, what is the equation we are having? N E square E by M tau. Correct? Am I correct or not? Now observe carefully. Compare these two equations. Compare these two equations. So you can write J is equal to properly N E square tau by M capital E. And below J is equal to sigma capital E. This is what we got it right. Yes or no, we are having this. On comparing, what is sigma? That's what I want. On comparing, what is your sigma? Which is nothing but equal to N E square tau by M. What is your sigma? Tell me. N E square tau by M. Correct? Already we got this, Sri Krishna, earlier. Correct? That's what I am writing here. Maybe I kept it here because we already got. That's why I wrote it here. I want to compare it with this notation. Which notation? This I want to compare with J is equal to sigma E. On comparing, sigma will be equal to N E square by M into tau. So what is its reciprocal? Can you tell me? Rho is equal to M by N E square tau. Observe carefully here. M is mass of the electron, constant. Yes. N means number of electrons. Correct? Small e means charge of electron. Tanushri, you know this, already went through it. You know this. I'm asking. That's why you're sleeping. Don't sleep. Do you understand this thing now? Charge of electron. What is this tau? Tau is relaxation time. Now observe. Now observe. I'm taking a material. Okay. அதுல ஃப்ரீ எலக்ட்ரான்ஸ் இருக்குமா? இன்னொரு மெட்டீரியல் எடுக்கிறா, அதுல ஃப்ரீ எலக்ட்ரான்ஸ் இருக்குமா? எஸ் ஆர் நோ? டு யூ திங்க் இங்க எவ்வளவு இருக்கு, இங்க எவ்வளவு இருக்குமா, டிஃபரெண்டா இருக்குமா? அதுக்குதான் ரோ இஸ் டிபெண்டிங் அப்பான் த மெட்டீரியல். எஸ் ஆர் நோ? ரோ இஸ் டிபெண்டிங் அப்பான் த மெட்டீரியல். ஏன்னா ரெண்டு மெட்டீரியல்ல சேம் ஃப்ரீ எலக்ட்ரான்ஸ் இருக்க மாட்டீங்க. ஓகே சார், நான் சேம் மெட்டீரியலே இருந்துச்சு. சேம் மெட்டீரியல் ரெண்டு காப்பர் எடுத்தா. ஓகே, ரெண்டு காப்பர் எடுத்தாச்சு. சேம் என் இருக்குமா? கரெக்டா? அப்ப both should have same rho, right? Remember, it depends upon now temperature. Sir, எப்படி சார் it will depend upon temperature? Remember, higher the temperature, the electrons will move more random, right? அப்ப இந்த ரிலாக்ஸேஷன் டைம் கம்மி ஆகும். ரிலாக்ஸேஷன் டைம் என்ன? ஒரு கொலிஷனுக்கும் இன்னொரு கொலிஷனுக்கும் நடுவில் இருக்கிற டைம் சொன்னார், ரைட்? am I correct or not? அது கம்மி ஆயிடுச்சு, ரைட்? அப்ப ரெசிஸ்டிவிட்டி என்ன ஆகும்? அதிகமாகும். Are you clear? That is the way it is depending upon the material and temperature. Who is depending upon material and temperature? Resistivity. Is that clear for everybody? That's what factors affecting electrical resistivity. So it is proportional to 1 by n. It is proportional to 1 by tau. 1 by tau when it will come into picture? If different temperature. 1 by n when it will come into picture? Different material. புரிஞ்சிச்சது நான் என்ன சொன்னேன்? என்ன எக்ஸ்பிளனேஷன் ஐ கேவ், யூ அண்டர்ஸ்டுட்? சப்போஸ் டூ மெட்டீரியல்ஸ் எடுத்துக்கோங்க, அந்த ரெண்டு மெட்டீரியல்ல சேமா இருக்க மாட்டேங்க ஃப்ரீ எலக்ட்ரான்ஸ். ஸோ ஆப்வியஸ்லி தே வில் பி ஹேவிங் டிஃபரெண்ட் ரோ வேல்யூஸ். எஸ் ஆர் நோ? சார் ஒரே மெட்டீரியல் எடுத்துக்கோங்க, பட் டிஃபரெண்ட் டெம்பரேச்சர் எடுத்தா electrons moving speed will be different, right? Collisions will occur quickly. Relaxation time கம்மியா இருக்கும். In that way resistivity will depend. Is that clear? Now you got the clarity. We are telling resistivity is a material property. Yes, it is a material property, but it depends upon the temperature. Understood? Yes, very good. So now see here, I wrote conclusion. So n increases, rho decreases. True. Number of free electrons are more, no? Conduct nicely. Yes or no? Resistance kammi. Number of free electrons kammi irunda, oh, more resistance. Yes or no? More resistance. Yes or no? N increases, rho decreases. N decreases, rho increases. Inversely proportional. I hope it is clear for everybody, right? Now, we said one strong statement. Resistance depends upon the temperature. How can you tell resistance depends upon the temperature? So just now, sir, if temperature changes, na, tau will change. Tau changes, na, resistivity will change. Resistivity changes, na, resistance will change. See the linkage. When resistance changes, same voltage, different currents you will see. Same voltage, different currents you will see. Or else more amount of the heat will be produced. More amount of the heat will be produced. That's why these all computers, they will put AC for them. In every school, even though computers are there, means they will put the ACs. Because they should maintain a proper temperature. Illana, they will get spoiled. Understand? They will get spoiled because at different temperature their resistance will be different. Different amount of heat will be produced. The components will get damaged. Understand? Fine. So now, okay sir, you said இப்போ நான் டெம்பரேச்சர் சேஞ்ச் பண்ணிட்டேன், அப்போ ரெசிஸ்டன்ஸ் சேஞ்ச் ஆகும். புது ரெசிஸ்டன்ஸ் எவ்வளோ சொல்லுங்க சார்? புது ரெசிஸ்டன்ஸ் எவ்வளோ சொல்லுங்க சார்? அது சொல்றதுக்கு நம்ம கிட்ட ஒரு ஃபார்முலா இருக்கு சார். புது ரெசிஸ்டன்ஸ் அண்ட் ரெசிஸ்டிவிட்டி ஆர் கிவன் பை R2 is equal to R1 into 1 plus alpha into T2 minus T1. What is the formula? Tell me. R2 is equal to R1 into 1 plus alpha into T2 minus T1. Change in temperature. Yes. What is the doubt? Yes. Okay. Rho 2 is equal to rho 1 into 1 plus alpha T2 minus T1. 1 plus alpha T2 minus T. Is that clear for everybody? Understand? Now, observe carefully. This alpha is the crucial here. Sir, temperature increase ஆயிடுச்சு, resistance always increase ஆகும் அப்படி இல்ல. There are some material, they were reverse fellows. Temperature அதிகமாயிடுச்சுனா அவனோட ரெசிஸ்டன்ஸ் கம்மியாகும். There are some fellows, temperature அதிகமாயிடுச்சுனா அவனோட ரெசிஸ்டன்ஸ் அவ்வளவு எஃபெக்ட் ஆக மாட்டேங்க. அந்த மாதிரி இருக்கு. So reverse இருக்கு. Clear for everybody? So that alpha is positive means it will be for the metals. That means for metals alpha is positive. Alpha positive indicates what? If temperature increases, resistance increases. Alpha positive means what? Tell me. If temperature increases, resistance increases. Correct? If temperature decreases, resistance decreases. Direct proportion. Sir, alpha is negative. If temperature increases, resistance decreases. If temperature decreases, resistance increases. Reverse. Okay. Alpha positive and resistance increases with increase in temperature. Alpha negative materials, reverse they will have. Okay. Alpha is positive for whom? For metals, keep this in mind. Okay. For insulators and semiconductors, alpha is negative. So resistance decreases with rise in temperature. For electrolytic solutions also it is negative. Keep this in mind. For electrolytic solutions also it is negative. Next. Understood, right, everybody? Yes. Now observe here. Observe here. For metals, how the resistivity versus temperature graph will be means it is increasing. Okay. As temperature increases, the resistivity goes on increasing. Clear? And for the semiconductors, it will decreases. It will decreases. Clear? It will decreases. Now observe, there are some special materials which are nothing but nichrome, manganese, and another one is constantum. Okay, these three materials resistance is less varying with respect to the temperature. They were like almost somewhat stable with the temperature. They are special alloys. Which are the three materials? Nichrome, constantan and manganese. Understand, these three materials, see, are used in wire bounded standard resistors because of their resistance depends less on the temperature. Okay, the resistance will depends upon the temperature konjam kammi. It is varying only. Okay, but not that much heavy increment. Is that clear? It's not that much heavy increment. It is somewhat stable. Clear that thing now? Constant slope it means. It's like variable. Further increase. Okay, fine. Next. Superconductivity. Sir, what is superconductivity, sir? Resistance வந்து 0 ஆகும். Resistance 0 ஆகும். Resistance இருக்க மாட்டேங்க அந்த மெட்டீரியல். அது எப்ப சார் பாசிபிலிட்டினா நீ சொன்ன ரைட், டெம்பரேச்சர் இன்க்ரீஸ் ஆயிடுச்சுன்னா ரெசிஸ்டன்ஸ் இன்க்ரீஸ் ஆகும். டெம்பரேச்சர் கம்மி பண்ண என்ன ஆகணும்? ரெசிஸ்டன்ஸ் டிக்ரீஸ். At a particular temperature, resistance மொத்தமா 0 ஆகும். That temperature is called critical temperature. That is generally minus 196 degrees Celsius. Minus 196 degrees Celsius. This is nothing but 0, it is 77 Kelvin. 196 degrees Celsius is 77 Kelvin. Sir, from 77 adukku below edu irundha it is a superconductor. The maximum possible temperature ella 77 Kelvin. Suppose I am putting it at 0 Kelvin. It is a superconductor. Am I correct or not? Minimum எவ்வளவு வேணும்? 77 வேணும். அதுக்கு கம்மி நான் 55 போட்டா. Will it work as superconductor? Yes. Sir, not for all materials. Okay. These are like high temperature materials. For them only. Sir, for others, sir, you can take minus 273 degrees Celsius. That is nothing but 0 Kelvin. Okay. So some of the materials will have they will have in the critical temperature at 196 minus 196, but some of them will have at 273. Some of them will have in middle minus 220 degrees Celsius also they are having. Okay, nariya irukku. The highest possible temperature na iduma clear. At this temperature all the metals will behave like as a zero superconductor. Sir, எதுக்கு சார் இந்த சூப்பர் கண்டக்டர்ஸ் ரெசிஸ்டன்ஸ் இல்லனா வேஸ்டேஜே இருக்க மாட்டேங்க. எஸ் ஆர் நோ? ரெசிஸ்டன்ஸ் இல்லனா வேஸ்டேஜே இருக்க மாட்டேங்க. That's why we need, if any precision kind of things if you need, you will use that. Actually in my lab I used to do work on some kind of thermal conductors. அதில் என்னன்னா, in that instrument I have to fill liquid nitrogen. எதுக்கு? To make that cool to minus 196 degrees Celsius. Clear? எதுக்கு sir you are cooling it to? Means to remove that resistance. In some kind of experiments we will use this. We can make the metal to be a superconductor just putting them into the liquid nitrogen. All of them. Because liquid nitrogen at a temperature minus 196. Okay, fine. Now observe, see this, as temperature is decreasing, resistance becomes 0 at 196. It's not for all, remember. Clear? Understand? Now see, superconducting materials are for efficient and lossless power transmission. Yes or no? We said lossless power transmission venumna, you should use superconductors. Next, powerful electromagnets. Want powerful electromagnets in MRI missions. MRI means, you know, one kind of scanning they will do, right? That is okay. And particle accelerators and quantum computing, magnetic levitation. This magnetic levitation is nothing but Japan or some China, they are running some kind of trains. They were not on the track. They were little bit above the track. So in that kind of stuff they were used to. And this quantum computing means it's like a powerful computing tool. Like computer is a computing machine which will perform the tasks. Like that quantum computing means which is engaged with so many things. Clear? So adula these kind of superconductors are needed. Clear that thing? Fine. And if you see, there are some cooling systems for nowadays computers. Have you seen liquid cooled computers are there? CPUs. Gaming computers you saw anytime? Yes or no? They will be having some kind of liquid cooling. Yes, or liquid cooling na in the mother resistance change aagakudadu. When you are playing, current will be passing through them, right? So to maintain constant cool. Sometimes when you are playing high powerful games, your mobile will get heated so much. Yes or no? Why, sir? This is the reason. And they will tell you don't talk in the mobile while keeping it charged. Charge put pesa kudadu, because power is going through that. When you are utilizing more heat will be produced through that. There is a chance it will blast. Then you can take leave. Okay. Now, limitations of Ohm's law. Sir, everybody will follow the Ohm's law. No, no, no. There are some people who are violating the Ohm's law. What do you mean by Ohm's law violation? Sir, who will be following Ohm's law? V is equal to IR. Whoever is following, they are following the Ohm's law. But when you take some good conductors, it was almost constant. But at the high values of potentials, high values of currents, it is not going to be straight. It is not straight. A little bit deviation will be coming. Clear? So some good conductors will disobey them at a high potentials, high potential difference. At the starting, they are obeying properly. Yes or no? Clear? At high potential differences, they will not be obeying. Is that clear for everybody? Yes. And one, see here. Actually, it should be like a proper sentences. You said there are somebody which are not obeying, right? The disobeying will be categorized three ways. Okay, one is violating this proportionality. Yes or no, we studied that. And I depends upon sign of the V, meaning if the potential I connected this way, ஒரு மாதிரி I will get. If I connect the battery reverse, I will get another kind of the I. So if you change the potential, I value differs. I value differs. I value depends upon the connection. That's what we said, sign. So relation between V and I depends upon the sign of the V. If current for a certain V, then reversing V, இப்போ நீங்க நல்லா பாருங்க, V வந்து 5 வோல்ட் வெச்சுக்கோங்கம்மா. அப்ப கரண்ட் பார்த்தா 2 ஆம்பியர் வந்திருக்கு. I reversed the current. அப்ப கரண்டோட டைரக்ஷன் சேஞ்ச் ஆயிச்சு. You should get again 2 ஆம்பியர் தானா? அப்படி வர மாட்டீங்க. நீ ரிவர்ஸ் பண்ணினா 0.006 ஆம்பியர்ஸ் வரும். அவ்வளவு கம்மியா வரும். Who are following that kind of rule means semiconductors. Semiconductors, not semiconductors particularly, diodes. Semiconductor diodes. We'll study about this in the 14th chapter, I think. The girl knows semiconductor diodes. Okay, and the semiconductor diodes கொஞ்சம் ஸ்பெஷல். என்னன்னா இது ஒரு சிம்பல் மாதிரி வெச்சுக்கோங்க. semiconductor diode சிம்பல். இங்க பாசிட்டிவ் இங்க நெகட்டிவ் கனெக்ட் பண்ணா ஓகே, இட் வில் ஓகே, நீ போங்க அப்படி they will tell. Understand? எப்படி சார்? let me connect it properly. Okay, I want to connect a battery. இங்க positive terminal, negative terminal, it will tell you go current. Understand? இல்ல அப்படி diode you did reverse. இங்க negative இங்க positive, it will tell wait, I will not send it. It will not send the current itself. If it send also, it will send very minute. Understand? That's why you can observe here. Voltage, positive voltage, meaning proper connection. Appa current அப்படியே increase ஆயிட்டே இருக்கு, right? When it is reverse correction, current is in microamps, very less. Is that clear for everybody? So what is the second point you can comment here? Relation between V and I depends upon the sign of the V. Yes, right? V is positive means current will be one value. V reverse panna, you will not get the same value. Okay, that is violating only, na? Yes. The third one, நீங்க நல்லா பாருங்க, ஒரு வோல்டேஜ்க்கு ஒரு கரண்ட் தான வரணும். Yes or no? There are some materials, ஒரே kind of voltage க்கு two different kind of current they will show. இல்லனா ஒரு கரண்ட்க்கு 2 to 3 different voltages they will be having. Okay, that materials are GaAs. Okay, gallium arsenide. Sir, what is that? Arsenide. Okay, so relation between V and I is not unique. Unique meaning ஒரு V க்கு ஒரு I இருக்கணும், ஒரு E க்கு ரெண்டு I இருக்கு, அந்த மாதிரி. It's not unique. Is that clear? Which material example? Yes. Which one? This one. Small current. The current passing through the circuits is small. That's why we are indicating milliamps. See, I can indicate amps, milliamps, microamp. Anything is okay for me. Oh, same graph, but you have to zoom big. So if I read the same thing in amps versus V, I may get like this graph. You understand? Or you getting small graph I will get. If I do with microamps, then I might have got a big graph. Difference. Your scale matters. When you plot a graph, you are taking a 1 centimeter equal to 100 potar, 1 centimeter equal to 50 potar. The size of the graph will be different. Are you clear with this? I want to draw this rectangle mark, which is 100 centimeter by 100 centimeter. If I am taking here 1 centimeter is equal to 1 meter. Okay, the 100 meter. 1 centimeter equal to 1 meter. அப்போ இந்த length எவ்வளவு வரும்? இப்படி பெருசா வருமா? அப்படி இல்லாம 1 centimeter equal to 50 I said. 1 centimeter equal to 50 I said. Then it will come more bigger than that, right? Am I correct? If I say 1 centimeter equal to 25 only, it will become very, very big. Annamadar, that is just a scale. Understand? Fine. Now see, those devices which do not obey Ohm's law are called non-ohmic devices. Okay, which will not obey Ohm's law are called non-ohmic devices. Is that clear for everybody? Okay, next. Combination of resistors. Combination of resistors. So resistors can be connected in series and resistors can be connected in parallel. When they are in series, same amount of current will be passing through them, right? Yes, potential will be different. That's why total potential will be V is equal to V1 plus V2 plus V3. And what is the equivalent resistance? Rs is equal to R1 plus R2 plus R3. Yes or no? Yes. When they are connected in parallel, V is same. V is same. Then I will be different. I is equal to I1 plus I2 plus I3. From V is equal to IR. IN and V by R. On substituting, you will get 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. Is that clear for everybody? Understood? Clear for everybody? Yes. Now, take the title Electrical Energy and Power. Electrical Energy and Power. If you remember, in your 10th class, you studied one thing. When current is passing through a conductor, heat will be generated. Am I correct or not? When current is passing through a conductor, heat will be generated. And you know very well, the heat H produced is equal to, H is equal to, what is the formula you know? VIT you know. Yes or no? Or else another formula, I square RT you know. Or else another formula, what is another formula? V square by R. V square T by R. Yes or no? These all formulas you know for heating. But what is the reason for heating you know? Current for the ulla, that's why heating was. Actually we studied that only in 10. Because we didn't go dig deep. We didn't dig deep. But inga konjam paranga. Edukku anda heat produce agardana. Sir, you said when electrons are under the electric field, they will get accelerated. Yes or no? They will get accelerated. Correct? Their kinetic energy should increase, right? Yes or no? Their kinetic energy should increase. But the kinetic energy is remains same. How you are telling kinetic energy remains the same. You said V is going to be a constant. Why it is becoming constant? Tell me. They are getting collisions. So when they are getting collisions, the heat will be produced. So when the molecules are getting collide with another molecules, this heat will be produced. Or else you can observe one more thing. For example, see here, some charge is moving from this A end to B end. Okay, that means we should be at high potential. B should be at low potential. Am I correct or not? VA greater than VB. Up the charges will move from left to right. Am I correct? Because charges will move from high potential to low potential. Positive charges. Whenever I am doing a theory, it should be positive charges. Keep in mind. Understand? Some positive charge is moving from A to B. So VA is at high potential. VB at low potential. So the charges at this location are reaching to at this location, right? When they are here, what is their potential energy? UA, which is nothing but Q into VA. Am I correct? When they are reaching to B position, their potential energy will be UV, right? Which is equal to Q into VB, right? Am I correct or not? Potential energy is nothing but potential into charge. Sir, you tell me UA is bigger than the UB because you said VA and VB. Clear? Am I correct or not? Understand? But one thing is true, total energy should remain constant. Total energy means potential energy plus kinetic energy. Potential energy plus kinetic energy. Some of the potential energy decreased, right? That means kinetic energy obviously increase agunum na. But on the increment edukku varla. Kinetic energy increment edukku varla na because of the collisions. Because of the collisions, heat is produced. Extra part is coming here. Heat. But still, the total energy remains constant. Still, the total energy remains constant. Here, not only potential kinetic, the third guy came into picture. Who is that third guy? Heat energy. Okay, that is what Joule's heating effect. Is that clear for everybody? You can observe this. If charges moved without collisions through the conductor, their kinetic energy would also change so that total energy is unchanged. But you said kinetic energy is constant. Am I correct or not? It is constant. It is throw out. The difference in potential energy should result into the heat energy. Heat energy is nothing but the difference in the potential energies. Keep that in mind. The difference in potential energy will result into the heat energy. Is that clear for everybody? So that energy which is dissipated is given by E is equal to Vi. Clear? Now observe, rate of change of energy is nothing but power, right? So divide E with time. What will you get? Power. P is equal to what? Tell me. Vi. Power is equal to Vi. Keep this in. Or else I can use another. Power is equal to what I can comment. V square by R also I can comment. Or else another formula I square R. This is what? Tell me. This is energy dissipated. Waste. Ennadidu power waste agaradu. Understand? Energy dissipated given by this formula. Understand? Now observe. Dependence of the power dissipated in a resistor on current in which voltage across it. So expressions for power show the dependence of the power dissipated, means the power how much is getting dissipated. It depends upon the resistance, on the current and voltage, all the three things. Understand? The power is depending upon the three things. What are those three things? Tell me. It is nothing but voltage, resistance and I. Is that clear? And the current. Next. Let's see. This is the point which I said why we need transformers. See this power loss in transmission. Nalla observe pannungama. This is our house. We are not producing any current. Am I correct or not? Current is produced somewhere very far from a factory. Okay, power station. Factory solo kudadu. Power station, not police station. From power station, it should come through some wires to our house. Am I correct or not? So every wire will have the resistance. Yes or no? Every wire will have the resistance. So when resistance is there, current is passing through that, heat will be generated. We will lose the, what we will lose? We lose the energy. Waste agu. Are you clear that thing now? Sir, tell me something. I want to reduce that loss. Loss agu kandipa. But reduce that losses. Clear that thing now? Now observe. Actually, என்னோட வீட்ல, for example, this TV only there. In the TV run ஆகிறதுக்கு I need some power P. Yes or no? Meaning I need to maintain some potential difference across the TV, that is V. Then only I will get the working of the TV. Correct, right? What are the data I want? I want P to be maintained across the TV. Adu maintain பண்ணறதுக்கு I need V. When V is there, I can expect P is equal to Vi. I want for my appliance. Is that clear for everybody? To run this appliance, I want this much of voltage and this much of current. Clear? So in the voltage, it need to maintain. Clear for everybody? Now observe here. The connecting wires from the power station to the device has a finite resistance. Correct? This is the wire which is from the power station to house. Power station to house. This wire will have the resistance, right? Am I correct? Resistance, fixed, right? Resistance on the wire nama change panla. On the aluminum wire that we are having resistance fixed. So you should write a power dissipation formula in terms of the resistance. Power dissipation formula in terms of the resistance. Sir, nariya formulas irukku sir namakitta. What are the nariya formulas you are having, sir? P is equal to I square RC you are having. Yes or no? Because the current that only should go to my appliance right here. So now replace this I with the potential difference. I with the potential difference. So what is that formula I in terms of the potential difference from here? V is equal to P by I can write. Sorry, I is equal to what I can write, tell me? P by V. That's what I want you to replace. So from here observe what you will get. P square by V square RC. This is what power dissipated through the conducting wires. Power dissipated through the conducting wires. This P is a constant, my appliance. Okay. This RC is also constant. Correct? Because on the wire nama change panla. It depends upon the voltage difference. It depends upon the potential difference. In that way, what they are concluding, to have less PC, V should be very high. Remember, to have the less PC. What is that PC means? Tell me. Transmission power loss. What is PC? See, I am not talking about my P. Appliance P na paaka matinga. Yes or no? I am talking about the transmission power loss. To have the less transmission power loss, V should be very high. Sir, but whatever the V produced, how will you increase that? You understand? Suppose the produced potential is 440 volt or 220 volt or 240 volt, some number it was produced. But to reduce the transmission loss, you said high potential difference in the transmission loss coming. Then we will take the help of step-up transformer. This step-up transformer, what it will do means, In the 220 volt or whatever it produce, it will make it to 7,80,000 volt. Avala persa it will make. Remember I said I saw that much potential difference. Understand? I told you also saw 25,000 kV supply. So 25,000 volt at the railway station. If you go to this road, there are underground cables. 40,000 volt. That yellow color board it will be kept on the road. That is 40,000 volt. Bigger than that. They are under the. Earlier it is out of the Chennai, I think. This place. You might have seen some kind of big power supply lines also in the city. Actually, normally they won't keep that high power supplies in the cities. Okay, outside the cities only they will keep. Sir, our high potential varudu. But if it comes to here, it will blast right. Then we will have another transformer, step down transformer. What they will do? They will reduce the potential level of they will be here. Is that clear? Two transformers we are having. Step up transformer, step down transformer. Step up to increase the potential difference. Why to increase the potential difference? To reduce the transmission loss. That's it. That is the reason. You understood why to reduce the transmission losses? Waste, sir. How it is depending upon the V? Yes, this is depending upon. Inverse. Yes, ma'am. Yes. Over. Okay, I hope you understood, right? That's it. Okay, that's it. Is that clear for everybody? புரிஞ்சிச்சா எல்லாருக்கும்? Fine. You just go through it. We'll study transformers. Okay. I hope it is clear for everybody, right? Please go through. You can leave now.